Okay, hey, we're back for part two of this week's discussion. I hope you all are well. I hope waking up to snow wasn't too alarming. I had this feeling that I woke up and all those signs of spring had just been a dream, you know? Um, Excuse the noise in the background. I'm sharing space with somebody here. Uh, I hope you guys have someone to share space with and that they could charm your life with little noises here and there. Um, sounds like it sounds like here's some news items for the summer crops class. If any of you are in it, I think a couple of you are. We're going to start a month late, or 3 or 4 weeks late, and make it a 12-week class that's blended. The first 4 weeks will be online, and the last 8 will be at the farm. So we're planting for it, we're planning for it, and that's the latest on that. So we'll get back to work. We'll get our hands in the ground. It's one of the safest activities you can do, just being outside far apart in your own little zone, pulling weeds and planting peas. Um, on that topic, let's get to the second half of this, where we're going to talk briefly about nutrients. In the first half of this discussion, we talked about what kinds of environments our annual food crops live in. They live in disturbed environments, and that pests were kind of a measure of soil health and how much dynamic integration we have with our garden system. This part's on plant nutrients and how and where they can get them from. Um, we usually split this into two groups, organic and soluble plant nutrients. And of course, you could do blends of both, and we do on the farm, we do both organic and soluble fertility. But before we knew about soluble fertilizer, before we found out about that in the early 20th century, everything was organic. Everything came from decomposing uh, living things like plants or manure. Now we discovered, humans being we, that we can feed plants soluble nutrients and they grow seemingly just as well, or at least well enough to finish and become food and flowers and everything that we use and eat as plants. So we're going to break that down quickly and hopefully thoroughly, so you have an understanding going into your life. So here we show, here I'll go to full screen. Organic in this way, so we have organic food, right? And organic food is certified to be grown in a certain way, mostly using organic inputs as fertility, but it also means using only plant-based or non-toxic to mammal pesticides. It also means using like crop rotation and other cultural practices to reduce the need for toxic pesticides and herbicides. But in this sense, when we talk about fertility, organic means anything that was once alive. So anything that's decaying from a living thing or as a organic byproduct. So like waste, like urine and manure. Um, Plants can get all of their nutrients from decomposing life and weathered rocks. So most of all the nutrients that are on, like my farm, for example, come from compost, animal manures. There's cows on this field that we're going to be planting in a couple weeks. So they wintered there, ate all their hay there, pooped it all over the place, and now we're going to work that material in, and that'll be our fertility source for the season. Weathered rocks means just like granite or any kind of rock when it um, becomes powder or fine enough has mineral nutrients in it. Some of the minerals that plants need, like sulfur, calcium, magnesium, manganese, selenium. These come from the weathering of rocks, the eroding of rocks. Soluble means, in the context that we're talking about plant nutrients, it means chemicals that have the nutrients plant use in a form that dissolves in water. So in the plant grow stacks at the FIC, you remember those with the blue water and the floating foam pads? That was soluble fertility. That means it dissolves in the water and it has the nutrients in a solution. that can go up into the roots when the roots take in water. It's true that plants can get all of their nutrients from chemicals that people make, so we can make all these things and provide all the necessary nutrients to crops to have them grow. So this is a new way of doing it. It's like 100 years old, and it's the way most of the world does it now. And it's led to some of the greatest expansions in the human population that we've seen or ever in history that we know of. Here's a chart that shows just how tightly gross domestic product, which is like the overall economic output of a society or a culture, tracks with its use of fossil fuel. So the blue line is how much fossil fuel is actually consumed. The black line is how much is pulled out of the ground. And the little green bars are the yearly GDP counts for a particular group. I'm not sure, this might be India. All major societies, all major nations track with this pretty closely. So this is just saying that all our economy is tightly bound to how much energy we use, and the more energy we consume, the more things we can make and do, and blah blah blah. So this might seem obvious to you, but the thing we should take away from this is that our economy is an energy-driven economy, and that soluble chemical fertilizer is a very high energy activity. Like, to make it requires big factories, machines, and 40% of the fossil fuel used by our society is used to grow food with. And that's not just tractors driving around. That's the bulk of that is just to make fertilizers. So it's not free. It doesn't just come from the sun. It comes from the ground now and the sun, and we're living with the results of that. Here's some example of organic fertility inputs and some of the elements that they contain. You'll note here that most organic fertility inputs have some of everything because they come from essentially whole foods or whole body parts. Like compost is made from all the scraps from a farm activity or your kitchen. And so if you have a broccoli stem or an onion peel, that had to grow in the first place, and it needed nitrogen, phosphorus, and potassium, and all the necessary minerals in the first place. So often those minerals end up in the scraps themselves. So that's a theme here with organic fertility, that most of them have a little bit of everything. So compost has NPK and all the necessary minerals. Manure is a lot like compost. It's just usually higher in nitrogen and leaner in a few necessary minerals. Fish blood and bone meal, these are like dried, crummy products made to be used as fertilizer supplements, and they're pretty high in NPK. And they're a byproduct from like the slaughter industry, basically. They don't use whole fish, they just use like the guts and the heads and stuff to make the meal. Same with blood, like when huge slaughterhouses just collect, lakes and lakes of blood, and they freeze dry it down or get the water out of it somehow, and it turns it into like a powder. Bones get ground up from meat factories. Those are all good inputs for soil. Limestone is just a rock that, if you recall from geology, is just made from the compressed like shells of little tiny sea creatures. Like there's like clams and seashells. Those are all calcium carbonate. And then when you get gobs and gobs and gobs of that for billions or millions of years to stack up on the ocean floor, it compresses and becomes limestone. So that limestone has a lot of calcium and magnesium in it, and we use that for those things. Then plant meals like kelp, alfalfa, soybean, those all have NPK and trace minerals. So it's hard. There's very few organic fertility inputs that is just one thing, one mineral, because most of them are life forms that had to use all the minerals to exist in the first place, so they still have it. Soluble examples, there's many of these, but these are just some just to show you that they come as a chemical formula, basically. So calcium nitrate has calcium and nitrate and nitrogen nitrate, because that's the chemical formula. So that you can put in water just like sodium chloride, and it would be clear. it dissolves completely. Ammonium nitrate has ammonia and nitrate, so those are the two forms that plants can take up nitrogen in. Potassium sulfate, potassium and sulfur, all the phosphates. There's different combinations of phosphates, but they all provide phosphorus. The little video after this is pretty good at spelling these things out, and it's got like a cute Indian accent, and it's like, to me, really sincerely put together, but kind of silly. I hope you appreciate it. Here it is. The quiz, I think this is all pretty self-explanatory, but give a definition of organic in your words. So just try to take all this discussion about it and give me a sentence that describes it. Do soluble fertilizers hurt soil microbes? I didn't really discuss that, but I will here. He discusses it in the short film too. But because there's strong concentrations, like salt is a preservative, and the reason it preserves things is because a really salty water can lyse bacteria cells, like burst them open because of the osmotic differential between salt water and the water that's inside their little bodies. So in that sense, we've used salts to cure meats, it keeps them from spoiling for a long time. So if you use salts for fertilizer, the same thing can happen. You could kill microbes, you could kill plants. Like if you put enough salt on a plant, it dies. But if you put the right amount of a salt fertilizer on the plant, it grows. So they have to be carefully handled, because too much definitely kills them. There's a top level of how much they can take, and I've seen this myself and made the mistake a few times. And the last is kind of a opinion piece. Like, would you have an approach that you would prefer? I'm not looking for you to tell me what I believe or what you think I want to hear. I want you to really think about it. How would you do it? And again, the little short film would be helpful in that. So great, thanks. I've been getting some of your crop calendars handed in. Thanks for doing that. It's not a bad idea to knock it out. Next week, Monday, I'll give you the exam sometime Monday. You could use it, take it home, get it to me by Friday, and then we're good. If you need to make special arrangements with me to do the other presentations or your paper, let me know. Yeah, I could answer your questions one-on-one if you email me or whatever. We could do a Zoom meeting or just correspond via email. So I miss you guys. I wish I could see you at the end of classes. It's really been a drag. I'm sure there's other worse things happening that this is making up for somehow. I hope we're keeping everyone safe by doing this. And I hope you and all your family members are well. And take care. I'll talk to you again. Bye.